Okay, today I thought we would do something interesting with the under-down shuffle. Now, for those who have followed the videos on my channel dealing with Bessey sequences, you'll know that the under-down deal is the nemesis of Bessey sequences. Why is that? It's because it's one of the few systematic shuffling procedures that destroys Bessey sequences. Just about all of the other ones preserve it. Okay, so the under-down deal is kind of an evil shuffle when it comes to the Bessey sequence structures that we look at on my channel. But I do want to point out that the under-down deal is not all evil. It's not all bad. So I have here 8 cards on the table, as you can see, of various values, suits, and colors. And so what we're going to do is we're going to use the under-down shuffle to help us find the answer to life, the universe, and everything. Whoa, if it can do that, it will certainly redeem itself as a questionable shuffle. Okay, now if you were here, I would have you tell me how many times to under-down shuffle this packet. But since you're not here, we're going to have to rely on this 6-sided die to decide that. Okay, so I'll go ahead and roll it. 4. Okay, we've got a little bit of work to do. Okay, so how this works is it's under, down, under, down, under, down, under, down, under, down, under, down, under, down. Last one goes on top. Now this shuffle is often couched as she loves me not in many of its applications. So let me just show you that since we need to do this shuffle 3 more times. She loves me not. She loves me not. Yes, no, yes, no, yes, no, yes, no, yes, no, yes. Good sign, good sign. Okay, well, we have 2 more of these under-down shuffles to do to satisfy the universe here that brought up a 4 for the die roll there. Okay, I have 1 more, okay? So hopefully you're checking me to make sure I'm doing these correctly. So under, down, under, down, under, down. Last one goes on top. Okay, well, at this point, what we're going to try to do together is find that answer that we're seeking, okay? And so I'm going to take the packet here, and I'm going to use my intuition to divide it into 2 piles of different sizes even, I think. I don't think they'll be the same size pile. And so I may have to be quiet during this time as I concentrate and focus my mental powers on doing this the way the universe would have me do it. Okay, so let's see what I can do here. So I'll put that one there, there. This one, yeah, it should go there. Left as well. Maybe, yeah, right, left, left, and then right. So it looks like I've decided on a pile of 3 and a pile of 5. Okay. Now, which of these 2 will be the pile we'll want? Not this one. I can certainly feel something unusual about that pile of 3. So we'll toss it aside here. Okay, so that leaves us with these 5 remaining cards. So how is it that these 5 cards can help us with finding the answer to life, the universe, and everything? Well, let's go ahead and just see what cards we got. Okay, so these are the cards we got. How would that help us? Well, I just had the impression just now that we should add up the card values. Okay, well, what do we get? 8 plus 7 is 15, plus 5 is 20, plus 10 is 30. Queen, let's see, Jack's an 11, Queen's 12, 42. We got a sum of 42. Now, as you can check, just jump onto your favorite AI system and ask them, what is the answer to life, the universe, and everything. And it will give you an answer of 42, which is exactly what we got. Okay, wow, we did that together. That's amazing. So now how does this work? What's going on with the mathematics of the whole thing? So this is the underdown shuffle, 8 cards. So I have the cards just numbered. Imagine them numbered 1, 2, 3, 4, 5, 6, 7, 8. So this would be like the top card, second from the top, third, and 8 is the bottom card. Okay. So if you've watched any of my Bessey Shuffle diagram videos, and there's dozens of them, I go through finding the permutation for various shuffles. Okay. And so if you watch any of those, you'll quickly learn the basics as to how I arrived at this line right here, and the graph as well, actually. Okay, so this is called cycle notation for a permutation. A permutation is just a rearrangement of a list of objects. Okay, so what this is saying here, in fact, it's really saying the same thing that the chart is telling us right here. Card 1 stays where it is. It's a fixed point. Card 6 doesn't go anywhere. It's a fixed point. Okay? And then what happens is the cards in position 2, 5, and 8 move around among themselves, which means, for instance, card 2, no matter how many underdown shuffles you perform, it will never end in the first position. Okay? So the cards in positions 2, 5, 8 will stay somewhere in positions 2, 5, 8 for all eternity. They just kind of cycle around. We call that an orbit in group theory. We have a second orbit, 3, 7, 4. So if you start at 3, it will then take you to 7, then 4. And then how this works, I guess I should explain this. When you get, like we were talking about, 2, 5, 8, and then the 8 gets sent to the 2. It like cycles around. 3, 7, 4, and then the 4 goes to the 3. Okay, so that's kind of how you read cycle notation for a permutation. Okay, so it's a very efficient way of capturing what it is this particular shuffle is doing to the cards in those various positions. Okay? So if you understand the idea of orbits, which is something I present on my channel, you can exploit that information and that understanding to create as many card effects as you like. Okay? So what I did here, what I decided to do, just realized that it would be helpful for me to write the position number above these, just for reference. So that's like the top card, second, third, fourth, fifth, 6th, 7th, and 8th card, which is the bottom card. What we have just talked about here is the cards in position 2, 5, and 8. They will just move around among themselves. So the ones I've marked as black, they'll just move around among themselves as you perform this underdown shuffle. Whereas the cards in positions 3, 4, and 7 that are marked red. So ignore the 1 and 6 for a minute because those are fixed points. 3, 4, and 7, those cards will move around among themselves. And then the fact is the cards in positions 1 and 6 just stay where they are. Okay. So what I have here is this is just one of several invariant structures that the underdown shuffle will preserve. Okay. We're still at the building a little bit of intuition stage here. Okay, so what I've done is I've actually created a packet of 8 cards. Top card is red, then black, red, red, black, red, red, black. Okay, so that's representing the colors marked down here. Now the claim is the underdown shuffle preserves this. Now you have to understand that most of the reds are moving around, even though we can't see that because they have red back, and all of the blacks are actually moving around among themselves. Okay, so let's go ahead and just do an under down. So under, down, under, down, under, down, under, down, under, down, under, down, under, down. Last one goes on top. So the claim is we've gotten back to the same color distribution that we had before, namely a red, so red, black, red, red, black, red, red, black. And that's exactly what we have here, okay? So in particular, what that would mean then is if you put certain cards in the positions where the black back cards are, technically it's blue, I guess, but anyway, so B for blue, I guess. So if you put certain cards in the positions of where we have these blue ones here, and then perform as many under-down shuffles as you like, they'll just stay there. Okay, you'll know where they are. You'll know where to go to find them at the end. They're going to be in those three positions. Okay, and then here I've just decided to have the two fixed points be red. Okay, so why did I decide that for this particular performance? Well, it's because I was going to create the narrative of finding the answer to life, the universe, and everything. So what I decided to do was put in the positions marked by red 5 cards whose values add to 42. So here's the Queen of Clubs, 5 of Hearts, so just focus on the value. So Queen's 12, plus 5 is 17, plus 8 is 25, plus the 7 here, 32, plus the 10 here, 42. Okay? And that's actually, if you go back, rewind the video, that's actually the order that I actually had the cards in at the beginning. Now, I want to emphasize that using this packet with this color distribution of backs is only meant to help us see that this structure doesn't change, the distribution of colors here doesn't change when you under-down shuffle it, okay? So that's the whole reason for introducing this right here. That's just meant to be a stepping stone to understanding the rest of this effect, okay? I've rebuilt the packet that I started with. This is the one I started with. So I had a queen on top and so forth all the way down to a 2, as indicated down here. Of course, as you can see, the queen, the 5, the 8, the 7, and the 10 are in the position that will stay there. They'll move around among themselves, except for position 1 and 6. Those cards are fixed. The other ones in positions 2, 5, 8, they'll just move around among themselves, okay? And that's the little pile of 3 we're going to throw out anyway, okay? So with this organization, and this organization came from understanding the permutation structure of the under-down deal for 8 cards, because understanding that, you can clearly see what its orbits are, what cards are just changing positions among themselves. Same thing here. So it's like the 3, 7, 4 are forever stuck in there. They can't go outside there. Same thing, 2, 5, and 8 stuck there. It's not as bad as 1 and 6. They can't go anywhere. 1 stays where it is, and 6 stays where it is for all eternity. They don't go anywhere. Very, very sad. So understanding just a little bit of mathematics really does give you power in the form of knowledge as to what shuffles are doing, and then using that knowledge to construct interesting effects that would otherwise seem impossible or highly, highly unlikely. Okay, so this is just meant to kind of give us a little bit of understanding. But with this packet built the way that it is, we can perform as many under-down shuffles as we like and not lose track of where our 5 special cards that we've placed in the positions marked by red, R for red, we'll know exactly where they are, okay? So I'll go ahead and just perform one of these, I guess. Under, down, under, down, under, down, under, down, under, down, under, down, under, down. Last one goes on top. Now, it's very important to understand that this shuffle performed once doesn't leave everything where it is. The cards in position 1 and over here 6 stay where they are, but everything else moves around. But the cards moving around within these orbits will not cause any issues for us, because the cards of interest to us, once again, are the ones in positions 1, 3, 4, 6, 7. Okay, and so if you remember, we shuffled it a number of times, decided by the die roll, or the spectator can decide that, or perform it while your back is turned. And now all you need to do, and so what I've done here, which I haven't explained till now, I've drawn a little black vertical line. The only reason for drawing that, it brings out a repeating pattern up to a point that will help you know how to separate these cards so that one pile of 5 has values that add to 42, and the other pile of 3 will be of no value to you. So you just set those aside. Okay, so what I'm showing you here is the particular, so there's many of them, many invariant structures we could have gone with. This is the one I went with. But if you look at it, it's not too hard to remember this repeating pattern. It's red, black, red, and then that same pattern again. Red, black, red. Okay. And then it's as if it's going to repeat that pattern again, but we don't have enough cards. Red, black, okay, but we've reached the 8th card, so you stop, okay? So it's just a clever way of helping you remember where the red cards are, and those are the ones that we will deal down into one pile of 5. So when I was concentrating and dealing to the table, in my mind's eye, I was just seeing the sequence red, black, red, red, black, red, kind of repeated. And of course, it stops here at red, black. So I went red, black, red, red, black, red, red, black, and I'm out of cards, right? So this gives us a pile of 3 that we don't need. And it also, of course, gives us our special pile of 5. And this is the pile, if we haven't made a mistake, it should be cards whose values add to 42, answering that most important question. Okay, so anyway, I thought I would just share this simple little card effect with you. Also, to point out that the underdown shuffle is a very useful shuffle. It's just it's not a very good one in the study of Bessey sequences, because it's one of the few actually that destroys the structure of Bessey sequences. But it has its own structure that you can take advantage of. So anyway, I thought I would just, and I'm hoping that this is maybe a motivation for you to take a look at the other videos dealing with Bessey shuffle diagrams, because you get a lot of practice with coming up with the diagram that represents what's happening with the cards in terms of how they're being moved around among themselves when a certain shuffle is performed, and being able to write that concisely in cycle notation, which is just a highly compact representation for what the permutation's doing or for what the shuffle is doing. And then from there, understanding these orbits, you can take advantage of that and design just endless card effects. So thank you for watching, and take a look at other videos on my channel. If you like this video, hit the like button. If you haven't already subscribed, please do so. So thank you again.